In today's video, we are going to see how to minimize a logical function by means of a Karnaugh map. Okay. Here I leave you the link to my video regarding the minimization of a logical function by means of Boolean algebra. The way to do this is to try to construct a square where to put the value of the function for the different combination of the variables. Okay, we are going to construct this square preferably symmetrical. Okay, so if we do this, we will get the following. So in this case, we have 16 possible combinations. That's why we have a 4 by 4 square. Here we are going to write A and B, C and D. I write them in this order to try to keep the weights of the variables in the truth table. Okay, so the next thing we have to do is to write possible combination for A and B, which will be 0, 0, 0, 1, 1, 0, and 1, 1. But we have to take into account that these values have to be logically adjacent. Okay, so in this case, I write 0, 0. The next one is 0, 1. And in order to be logically symmetrical, I will have to write 1, 1 and then 1, 0. And the same for the upper variables. I write 0, 0, I write 0, 1, 1, 1, and 1, 0. I have to divide the square in symmetrical parts, so I'm going to write this here, okay, this here, this here, this here. So this part is mirrored with regards to this to this, this to this, and this to this. It is going to be useful for me in order to group the terms together and minimize the function. Then I have to fill in the blanks. In this case, for 0, 0, 0, 0, I have that the value of the function is 1. For 0, 0, 0, 1 is 0. For 0, 0, 1, 0, 0, 0, 1, 0 equals 0. And for 0, 0, 1, 1, 0, 0, 1, 1 equals 1. For the next row, 0, 1, 0, 0, 0, 1, 0, 0, it yields 0. 0, 1, 0, 1, it yields 0. 0, 1, 1, 0, 0, 1, 1, 0 yields 0. And 0, 1, 1, 1, 0, 1, 1, 1 equals 0. The following one, 1, 0, 0, 0, 1, 0, 0, 0 equals 0. 1, 0, 0, 1, 1, 0, 0, 1 equals 0. 1, 0, 1, 0 equals 1. And 1, 0, 1, 1 equals 1. And the last one, for the value 1, 1, 0, 0, 1, 1, 0, 0, the function equals 1. For 1101, the function equals 1. For 1110 equals 1, and for 1111 equals 1. So I have to group the combinations that are logically adjacent. Okay, I'm going to group them taking into account that I'm going to minimize the sum of products. So I'm going to take into account the ones into the table. So here I can see that I could group this with this because they are logically adjacent. Look, 1 1 0, and the only value that changes between those two is D. So I could group this. In the same case, I can group this with this. They are logically adjacent. There is only one variable changing from one to the other, 1 1 1 1 1 1 1 0, and I can group these together. And as this term is mirrored with respect to this, I can group these together. Okay? So for the first term, I could write f equals, I'm going to take into account the variables that don't change between these values, and the only variables that don't change are a and b, whose values are 1. So for this I can write, by minimizing, that this yield a and b. A and b. Those are the only variables whose values don't change during this along this row. Okay. So the next one, for example, that I'm going to take into account is look, this and this. I could group this because they are logically adjacent. I'm going to group them. Okay, so I'm going to write the values of the variables that don't change between these two values. A and B negated, and C. A and B negated, and C. There are two terms remaining, which are this one and this one. Okay? For example, if I take this into account, I have to try to look for another one which is logically adjacent to this one in order to simplify it. The only one is this one. Okay? So I take these two together, and the corresponding term will be A changes. Okay, I don't take it into account. It will be B negated, and C and D. And the remaining term will be this one. The only way to group this with another term in order to minimize it will be a term beside next to this here, for example, a term here which will be logically adjacent, or a one here which will be logical adjacent, here, 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 or here. There are no ones in these boxes, so I cannot minimize this term, so I will write it this way: A negated and B negated and C negated and D negated. This will be the simplified logical function taken from this table and simplified by means of the Karnaugh's map on the right, and by taking into account the sum of products. In the following case, we are going to minimize the same logical function by means of taking into account the product of sums. So I'm going to take into account the zeros in the Karnaugh's map. Now we are going to get the minimize function as a product of sums. So in this case, we have to take into account the zeros in the square, okay, in the Karnaugh's map. So I write f equals the same as before. I could group this with this because they are logically adjacent, because between these two terms only one of them changes, which is D. I can group these two together, and as these two are mirrored, I can group these four together. So I will write this as the terms that don't change, the variables that don't change in these terms. In this case, we are going to take the negated as non-negated and the non-negated as negated. We will write this as A or B negated and I can group this with this because they are logically adjacent. Only one variable changes between these two terms, which is D. So if I group these two together, I get A negated, which doesn't change between these two terms, or B or C, which is the other term that doesn't change between these two, the other variable that don't change between these two terms, okay? The following one, for example, could be this zero. I can group this zero with this zero because they are logically adjacent. Only one variable changes between these two terms, and that variable is A. So I can group them together, and I will write this as B, which is one variable which doesn't change, or C, which is the other variable that doesn't change, or D negated. and the remaining term, which is this one, this term doesn't have another logically adjacent term next to it, so I cannot minimize it. So I will write it as A or B, which are variables that don't change, okay? Or C negated. Remember that we are writing this as a product of sums, so I have to write the ones as negated, C negated, or D. So as you can see, the way of minimizing the logical function by means of the Karnaugh map is the same than in the previous case, but the difference is that you have to group the zero which are logically adjacent. And we write this as product of sums. I hope you liked it, and I see you in the next video.